Hello everyone, my name is Vikas and this is another session from Tutorials Diary. So in this session we'll talk about inheritance in Solidity. So we already covered some of the concept which we have in Solidity like the error handling, logging, abstract contract, and then what interface means in the Solidity and how it works in the real time in the Solidity. So in this session, we'll talk about the inheritance. We'll first of all discuss some theory part. We will explain that the concept behind inheritance. Then we'll show you a quick sample just to understand it in more detail. So let's get started. So the very first question comes in the mind is what is inheritance in Solidity? So you might have heard this concept before in Java or other programming language. So the concept remains same here as well in Solidity. There is nothing new here in Solidity which we are talking about here. This is the same concept which we will talk about in the same session. So inheritance at layman term, this is like a parent-child relationship. Okay, when the child born, he or she will have some features or some properties from the parents. So same way when we talk about inheritance, what we do in this programming language or in Solidity, we create a parent contract and then we create a child contract and then child contract get inherited from the parent contract basically. So whatever variables we have or the function which we have defined in the parent smart contract, that will get accessible in the child contract as well. So based upon the visibility which we set for variables and the functions. Okay, so basically this is how it will look like. We'll show you that how the contract will look like when we talk about inheritance in Solidity, but this is at very high level. So this is kind of parent and child relationship which we have in the programming language. So inheritance, as we just mentioned here, Solidity does support inheritance as other programming language. So this is one of the example which we have put, which will show you in the hands-on also. Like you can assume that you have a contract with a name member, which has one function defined with a variable set name. So here what we're trying to do, we are trying to set the name for the member. So now that member can be anything. Okay, it can be your teacher, it can be your principal, it can be your student, it can be your administration person, it can be any member. If you take the example for school or college, it can be any member, right? So this is a general contract which we have defined now. We are using that contract to define our specific members like teacher, student, principal, and administration group or HR group, and so on. So in inheritance, we use the word keyword is. So in other programming language, somewhere we use extend, somewhere use other keywords, but in Solidity, when we talk about Solidity here specifically, we are using the is keyword here to inherit a contract. So the point here is that you can inherit more than one contract as well. You can just have a comma separated value like member, comma, something else. So this way you can inherit more than one smart contract inside a contract. But here this is a very simple example which talk about that how a contract can inherit another contract. So now when you inherit a contract inside another contract, what happens that all the variables and all the function which is defined in the parent contract will get accessible in the child contract as well. There are some other points which you have to take care, which we have to consider when we say it is accessible or not, but at very high level in general term, we're talking about that all the functions and variable will be get accessible. So you need not to write the same piece of code again and again. So what you can do, you can create a parent contract which can be accessed through the functionality can be accessed through the child contract as well. Okay, so we'll talk about more in the hands-on session about how this will look like and what all possibilities which we have in this inheritance in the Solidity. So there are a few facts which you have to remember. So when we talk about inheritance, as we just spoke about that, okay, you can have a parent contract and the child contract can inherit the parent contract. Now we also mentioned that a child contract can inherit multiple parents. Parent 1, parent 2, parent 3 and parent 4. So what happens when we deploy that child smart contract on a blockchain? what happened in the real time as a runtime, basically all the codes which you have in a parent contract, it will get copied to your child contract and it become only one smart contract. So suppose you have three parent contract and one child contract, and child contract is inheriting all three parent contract 1, 2 and 3. So whatever code or functionality which you have in parent contract 1, 2 and 3, it will get copied to your child contract and that become only one contract. Okay, and that will get compiled and get deployed on a blockchain. So don't it is not like that you will have four contracts getting deployed on a blockchain. No, it will be only one contract which will get deployed on a blockchain. There are some access modifiers here, as I just mentioned, that okay, how you can, when child contract inherit parent contract, it will be able to access all the functionality, all the variables and the functions. But there are three main keywords, but I have just mentioned about two here, which is main here. There are three keywords, which is public, private, and internal. So when we use public keyword, that means all the variables, all the functions are accessible throughout. Anyone can access that variables and the smart contract and the functions. But when we say private, private means that variables, that state variables or the functions can be accessible only within that smart contract. It will not be accessible in the child contract as well as outside of child contract, right? So that is private, but it is internal. So this internal is similar to the other keyword. So we used to have in Java, if you talk about, we used to have public, private, protected. Protected is the keyword which we used to have. So same way we have internal keyword here. So when we use internal keyword with any variable and the function, so that variable and the function will be only accessible in the child smart contract, not outside. Okay, so we'll talk about more, we'll show you more about this one in the hands-on session, but this is a few facts which you have to remember about inheritance in the Solidity. So let's move to the hands-on session. Let's see that one, how we can do the inheritance. So first of all, let me clear this one and create a new smart contract with the name, new Solidity file with the name inheritance. So what I will do, I will just start with Pragma, Solidity. I'm going to use the version as 0.4.20. Now what I will create here, I'm creating a parent contract here. So my name of parent contract is member. Okay, so now what I will do here in this one, I will create two variables. So member can have a name and age at very minimum level. Okay, let me create a variable with the name and unsigned integer age, and it will also have a salary, right? So now what we want to do, this name and age anyone should be able to see. This should not be private or internal, right? But salary should not be visible for everyone. So suppose my salary should not be visible to some other person, right? So we always want salary to be private only. So what we'll do here, we'll make this salary as private. Okay, so now let's talk about the functions here. So we are defining the two functions here, like the get name. To get the name, this will be public. This will be again accessible by anyone, and this will return your name. Same way, we will define get age. Again, this will be public, returns unsigned integer. This will also return age. Now, so this is pretty much we have. Now what we'll do, you can this is a very basic function which we have defined just now. Okay, that you will get some warning. Okay, so this should be a pure function basically it is talking about here. Okay, so this is just you can ignore this warning for now. So this is my parent contract. Now what I will do, I want to create one child contract with the name contract teacher. So teacher is one of my member. Okay. Then to inherit from a parent, I will use a is keyword. Then I will say member right here. Now, what happened here? As soon as I use this is keyword, whatever variables, these two variables only, name and age, these two functions will get accessible inside the teacher smart contract. Okay. Let's see first of all. Let's compile. Okay, both. And let me do one thing. Let me show first of all about member. So member you can deploy easily. Let me delete everything. You can see you are able to deploy member, which will have name and age. Okay, then you can also try to deploy teacher. So once you deploy a teacher, let me show you teacher as well. This will get two functions. Although we haven't defined this function, but because these functions are being defined in the parent smart contract, that become accessible in the child contract as well. Now what we'll do, we'll just make one more change here. We'll define a constructor. So constructor, we already have a session, a separate session on this one. So I would recommend you to go through that session in the detail where we explain about constructor, what that really means. So you will define constructor here, okay, and that constructor will accept two values. First is string name, age. So what we do in this one, we'll assign the name to name and age to age. So this is how it can be used. Now what you do in this one, as soon as you inherit the member, you can also define, you are calling the constructor, you can call the constructor as well. When you inherit this one, you can pass the value as like mark and 34. So this is how it can be also used. Now let's compile this one. Let's see how this will behave. Now let's go ahead and deploy the teacher. Let me delete this one and make it clean. Deploy. So once you deploy this one, you will get, let me clean this up. Now as soon as I get the age or name, let me click on get name. So if I just expand this one, you should see mark. You can see the output is mark, right? So how this worked, when we call this teacher, when we have inherited, we have inherited from a parent contract, but we also call the constructor of our parent smart contract. So we have passed this value name and age there, and that will get assigned to the variables name and age variable. And then we have accessed get name function that will return the value which we have set. So we have set the value as mark, right? So same with the get age as well. If you access the get age function, you should be able to get the 34 value, 34. So now you can also extend this teacher contract. You can define your own functions here. Okay, you can also define, okay, like you can define anything like here, okay, identification mark like. Okay, so this will be like public. This is up to your requirement. This should be public or not. On chin. So let's see. This is how now when you will try to deploy it. Let's compile first of all. So just try to make this a practice. First of all, compile and then deploy only. So let's deploy this one now. And now this new teacher contract should have three functions. Two inherited from the parent and one is its own functions here. Now, so this is how it works basically. Now, if you try to access salary here, you will get some warning. Because salary is defined as a private variable. It cannot be accessible outside of this parent contract. But if you make it internal, then you can access it here. Then you should be able to access it here. So this is the difference between private and internal. Public, if you define it public, that means it is accessible all over. Within the contract, in the parent contract, child, or outside as well. So these keywords are helpful based on your requirement. Either you can define the variable as private or internal or public. Okay, so this is how inheritance work, and as I just mentioned the PPT also, you can inherit more contract as well, more parent contract as well. There is no limit basically. But what happens in the real time, whatever codes you have the parent, it will get copied in the child contract when you deploy on a blockchain, and ultimately only one contract get deployed, not two contracts. So this is how inheritance works in the Solidity. I'm hopeful that you like this video, and thanks for watching.